Okay, I think we're still getting people joining, so we'll just wait until it dies down a bit and then we can get started. Okay, maybe just a little longer. I think we're up to around 50 something. Okay, I guess maybe we'll go ahead and get started. And we've got quite a lot to cover, so as people come in, we'll let them in. But thanks everyone for joining, registering, and joining our webinar today. It's about AI-powered health economic modelling, a practical guide. So really, this initiative came about early this year once we started. Once there was the release of Claude by Anthropic, and we started using it, we realised how powerful it was, a tool to develop health economic modelling. So since then, we've developed a couple of white papers and this webinar as well. So without further ado, I'll get started and we'll just start off with some introductions. So these are the speakers today. I'll just tell you a bit about myself. So my name's Ray Garney. I'm the Executive Vice President of Health Economics and Value and Access in the European team at PharmaQuant. My background is in health economics, so I've been doing it for over 20 years now. I've worked in industry, a range of different consultancies, and also public health. So I really enjoy modeling and very excited about these innovations. I'll pass over to Shubhajit for intros.
Hi, Ray. Thanks. Nice to meet you all. This is Shubhajit here. I've been part of PharmaCons since about 7 months. I lead the economic modeling team based out of India and also lead AI and innovation activities, apps, etc. I have nearly 15 years of experience, primarily in HR in Novartis. That stint was about 10 years. Apart from that, rest of my experience is mostly in AI, machine learning, in commercial analytics. So yeah, looking forward and excited to present our approaches and frameworks and tools, etc. So yeah, I will hand it over to Ian.
Thanks, Bridget, and very good to speak with everybody. My name is Ian Fotheringham. I'm the Vice President of Value and Access here at PharmaQuant. I'm also the Product Director for a program called Active SLR, which I'll be doing, providing a quick demo of during our webinar today. Been working in consultancy now for 17 or 18 years or so, predominantly focusing on evidence generation. But I started with my degrees in economics. So looking forward to speaking with everybody today.
Okay, thanks, guys. So in terms of the agenda, so we'll just start off with an overview of HR and how AI can be integrated into workflows. We have an example of a workflow for health economic modeling. So this is just to show you how this can be constructed. And then we have three demonstrations. The first, a model builder, looking at concept and specifications for health economic modeling. An AI-assisted literature review. So this is a very robust method of collecting data that can be used in the models. And then we've got a demo around constructing health economic models using Claude and in Excel. Then we've got a couple of slides just about confidentiality, some of the potential pitfalls associated with AI, using AI, then integration, AI integration and partnership models. And then we'll finish with a discussion and Q&A at the end. So feel free to put in any questions or comments as you think of them in the Q&A chat function. And then we'll either pause to answer questions throughout or we'll answer them at the end. Okay, so in terms of the health economics and outcomes research landscape, there are lots and lots of problems that we face these days as health economists, and a lot of them are focused are out of our control. So we've kind of put together a list here of some of the key ones. The first is around evidence overload. We spend so much time trawling through evidence. There's a lot of research out there, and the amount is increasing. So it's increasingly, in order to produce robust results, we need to review this evidence. There's also different methods available, technical methods to analyze data. Again, this can be quite labor intensive, but it has to be done in order for us to optimize the methods we use for economic modeling. There's also limitations in terms of the type of analysis, the amount of analysis we can do. So we have to, even though we may want more time, even though we may want to do more scenarios, there's a limitation on how many we can do. And there's also evidence gaps. These need to be spotted early in order to make sure our analysis is robust. And the uncertainty can create delays, especially if we find these gaps too late. We often have fragmented workflows. So we have lots of different data sources, lots of different analyses ongoing. All of these things may be separated. They all need to be pulled together so we get a coherent vision. But this, again, requires additional effort, additional alignment, and can lead to inefficiencies. And all of this leads into our decision-making processes. And one of the key things that we want to do is make sure that we can reduce uncertainty. There's always going to be uncertainty in the way that we do things, in the data that we analysis. But one of the things that we want to be able to do is minimize this uncertainty, making sure we're using the best available data, best available methods to reduce uncertainty in our decision-making processes. So what does that mean in terms of AI? How can AI support some of these tasks? Well, I'm sure a lot of you guys have already used AI in some capacity, but the key benefits are around repetition, reducing repetition, doing analysis, processing, and summarizing. So just in terms of those HR challenges, so in terms of evidence overload, there are AI solutions around identifying, reviewing, and summarizing data. And that's something that Ian will show soon. There's looking at the different methods, so prioritizing options, their suitability, pros and cons. And in some of the work that Shubhajit's going to show, we look at different modeling structures, different types of models, and how those can be compared and assessed. There's an analysis limitation, so automation can increase the scope and the breadth of analysis that's undertaken. In terms of evidence gaps, we can do that quite early now. Once we have the AI agents in place, it's relatively straightforward to do gap analysis. We can use the different AI agents to join different analyses together so that we have a good flow of information, a constant flow of information. And in terms of the decision uncertainty, we can use AI to bring this information together to help us generate insights. So really all the decisions, all the QC sits with the health economist, but it's about automating some of these more routine tasks, more predictable routine tasks to free up time to generate those insights. So how does AI work? So we've put together just this slide about how it works. We're not going to go into LLM models or the technical aspects, but really just focus on what's really relevant from us as in terms of how we use AI in order to develop it in a way that can support our decision making. So the first thing to understand about AI workflows is around tokens. So tokens are actually the smallest units that the large language models use. So when we put in a prompt, that's broken down into tokens. The tokens are very small, 3 to 4 characters, and the LLMs take those tokens and they use that to predict the responses, the outputs, and those outputs again are built up of tokens. So really these are the building blocks of everything. Just a couple of points about this. The more tokens you use, the slower it takes to generate the answers. And also many of the providers, AI providers, they base their costs on numbers of tokens used. So efficient use of tokens, it makes things more quick and less expensive. The next point, which is probably where most people are, is in terms of prompts. So the prompts are the questions that we ask the large language models, and really sort of well-constructed prompts provide better answers. And I think that's the key part here. Longer prompts not necessarily produce better answers. Quite often, if the prompt's too long, the large language model might not digest the whole thing. It might give you a partial answer. So well-constructed prompts are essential to getting good outputs. So good inputs would produce better outputs. But the real power, and what we're really going to focus on today, are the agents, the AI agents. So the agents are more than just a string of prompts. They're actually a way that AI can interactively work with its own outputs in order to provide sort of quite powerful outputs at the end. So the way it works is you have a chain of prompts, and each prompt addresses the outputs from the previous prompt. So doing this, you can have autonomous multi-step workflows. And really this is one of the key parts of using AI effectively, is developing these agents and making sure that they build up through connected prompts, which enable you to essentially outsource workflows to the AI. So just in terms of some of the benefits, so efficient tokens leads to lower costs and latency, so you can get things done more quickly. Clear prompts can drive accuracy, and having smart agents can automate complex workflows. And that's really what we're going to focus on today, is some of these workflows. This next slide is around some of the agentic workflows for economic modeling. And this shows how you can construct this. So it's just a schematic of how you can go about constructing AI agents to develop these workflows. So if we just look at a traditional model development, you'd start off with the concept and specification. You would then work out the inputs and assumptions, build the model in Excel, review and validate, and analyze and report. So this is a normal workflow for a model. So one of the things that you can do to support this, to make it quicker and to review more information in depth, is to augment each of the steps. So you can develop agents to do each of those. So for example, when it comes to the concept and specification, you can develop the P codes based on published sources. So it's something we'll talk about a bit more today. You can look at modeling options, compare and contrast those. When it comes to inputs and assumptions, again, you can use the AI to compare data sources, to do gap analysis, to look for data, look at different data sources, the databases. One of the key points here is that you can tailor it to look at robust sources, so like peer-reviewed publications. So essentially you end up with summaries which can be traced back to peer-reviewed publications. When it comes to the Excel model, and like I said at the beginning, this is really where we started. One of our starting points was the availability of Claude, which was able to produce pretty good Excel models based on the model specifications that we were feeding in. So it's very good at providing like early draft models, which are then further developed by hand, but it saves time in terms of that early development. Claude and other LLMs can support with the verification checks, with the external validation. One point to kind of flag here is that there are issues with in terms of confidentiality when it comes to AI. So we'll discuss that in a bit more detail. But there needs to be this division between what's done in AI and what's done outside, and that there's a barrier so confidential data isn't shared with the AI. And then the final part around analyzing and reporting. So AI can be used to draft external materials as well. So just in terms of a summary of some of the benefits, there's the automation of tasks, rapid reviews, there's the error detection and verification of models. We get the opportunity to do more exploratory analysis because there's more scope to include those. And then you can have faster iterations, so you can actually go back and change things. So you want to change the comparators, you want to add in different subgroups. You can even change model structures, go from partition survival to a Markov model. These things can be done a lot more quickly because of the automation. And really what this does, it frees up time for more focused discussion. So you get that opportunity to spend less time on these fiddly repetitive tasks and more time thinking, developing insights and looking at decision-making activities. So with that, I'm going to hand over to Shubhajit, who's going to talk you through some of the apps that have been developed and how those have been constructed. So Shubhajit.
Yeah, thanks, Ray. Thanks, Ray, for the introduction so far. So as Ray mentioned, we can break down the process of developing an health economic model into certain discrete steps. And the essential idea is to develop an agentic AI framework, which consists of some apps in some places, some framework or some process essentially, which will integrate all these agents together and all. So the first one that we will talk about is a app or a tool for developing concepts and specification, which is typically one of the most time-consuming parts of building a model. Essentially, you need to integrate a lot of data sources like clinical guidelines, epidemiology, different publications, expert opinion, etc. We typically use them in a sort of a structured process. Here we have identified a 6-step process where we start with developing the decision problem or sort of specifying the decision problem. Then we expand upon the disease pathway or the disease nature of the disease. Then we move on to building a structure based on the decision problem and pathway. Let's say Markov model or a simulation model, etc. In the 4th step, we essentially go in depth into the specifications of the structure itself. For example, number of health states, the types of health states, etc. Then we move on to building up the parameters, the set of parameters that will go into the model. What are the input requirements? Where will we get those inputs, etc. And lastly, we integrate all the information together in a report, which is typically called a model concept or a specification report. Now, our tool also has the same sort of a structured process, but we focus mainly on the human plus AI integration through intelligent design and using AI for automation so that human inputs are required for verification, validation, and decision making. So that's about this. So that's about this slide here. I can move on to the demo itself. But before that, I just want to highlight that there are parts of this tool, for example, the parameters. It does not actually, take the parameters through an SLR or TLR. So that is a separate process that Ian will go through. But it will identify the parameter list. that can go into a health economic model. Yeah. So maybe is it okay Ray, if I share my screen and start the demo of the tool?
Yeah.
Please let me know if my screen is visible.
Yeah, can see it.
So, so two caveats here before I go through the tool. One is that this is a prototype internal tool which we are developing currently. We'll make a sort of tool or app out of it, and we aim to launch it in next 2 to 3 months. So that stay tuned for that essentially. And I'm gonna create a demo on the fly. So this is not pre-prepared. So there might be some sluggishness or some delays here and there, but I think we should be okay. So we start off with the tool. On the left hand side, you see the 6 steps that we talked about. Decision problem to right through specification. There is also an experimental dashboard section, which I will come to when we go there. We also have option to upload certain documents here. I'll just quickly upload them and then show what exactly I'm uploading. Um, then in the main section for the first step, we have the decision problem. We can also upload documents here. So this is the global context, which will be applicable to all the steps. But within each step, we can also download or upload specific documents. We will also have a Pico framework where I will put some inputs. There is a progress bar on top to show the progress of going through the various steps. So here I have chosen a disease area of atopic dermatitis. I have uploaded 2 of the publicly available papers. One is a nice TA and another is more of a disease guideline. So these 2 I have uploaded here as a context or as a basis for the further development. Next, I will add some of the text here to identity define the PICO. So adults with moderate to severe atopic dermatitis. In intervention, I will add a hypothetical intervention called ABCMAB. Also another hypothetical intervention or a comparator. And I will add a few outcomes that need to be assessed. Okay. So I have provided few of the inputs, and also I have added some of the global context files. I will just save it here and move on to the next step. So in the first step, I have provided the PICO. In the next step, it's more about defining the disease in terms of natural history, clinical events, etc. Here also, I can upload some of the specific disease guideline documents in this page. But since I have uploaded earlier, I will just use the extract pathway. So essentially, it will go through the files that I have uploaded. So I'll just project them once more. So it will go through the files that I have uploaded and try to extract the relevant information from here. So notice that I'm including information from my end in various stages, but also I'm letting the AI take over in some stages. So it depends on how much you want to put or how much how much of the human context you want to provide. Maybe it's not maybe it's not fully understood from the documents themselves. Maybe you want to add free text. You can also add things like expert opinion, KOL, inputs, and other sort of documents. So there will be a limit of number of documents that can be uploaded, both on the global context as well as the step-specific context. But I mean, for now, it's just for a demonstration of the tool. Yeah. So it may take some time depending on the size of the document. As you can see, the documents are quite extensive with various images and information and things like that. So just give it a minute. So it took a bit of time, but as you can see, it has extracted some of the natural history and important clinical events from the context that has been provided. I will just move on to the next step. And in the next step, essentially, we have provided the decision problem and the disease pathway. In next step, we will let the model decide let the AI decide the model structure to be used. So essentially here we will generate recommendations in terms of what sort of model structure that can be used. We are also experimenting with more inputs here. For example, here we can add a specific model structure publication or a free text input to, check with what sort of model structures can be used. As you can see, it has generated a recommendation of a cohort Markov model structure. It has also added key assumptions and limitations of this model structure and added a scoring matrix which assesses its performance compared to other types of models. We also had a variation of this tool where user can change it to a different model structure, but we felt that we can skip it for now in the development process. But essentially, based on the given information, it's constructing a model, recommending a model structure, followed by the key assumptions behind the structure, limitations, references, as well as a sort of a scoring matrix in terms of various aspects like memory, event, data availability, preferences, ease of use, etc. Okay. So in the next section, we can again provide some of the inputs, like, for example, again, a model specific publication. We can provide some instructions optional, like include a certain health state or certain behavior. So I'm not adding anything of that sort right now, but I'm just letting it generate a health state based on the information that has been provided to it. So what it will do is that since we have decided upon a cohort Markov model structure, it will generate a health state sort of a matrix and a diagram here. As you can see on the top, as we are progressing, the progress bar is also increasing, and the steps we are increasing. And it's so as you can see, it's created a model structure. It's given a rationale and the health states, whether they're transient or absorbing. It has also given a diagram. The specifications and some of the details around it, we are still working on to make it look better. And but essentially, this is the idea about how it will generate the Markov health states and diagrams. I can give some text instructions to update it as well, but I'll just move on in the interest of time. So once I'm happy with the health states that have been created, I can move on and generate the list of parameters to populate this model. So what it will do is that it will generate a list of input parameters, some hypothetical values, and also some, by hypothetical values, I mean placeholders. So these are not like coming from a TLR or an SLR or a systematic process. It definitely needs independent validation. These are just starting points or just some placeholder values to populate or create a model. Yeah. So and after we do it, it will be available for a download as well. So yeah, so again, as you see that we have moved on to four stages, and we are at the fifth stage right now. So whatever input I have given gets fed into the system, as well as the user defined or the user defined text I have added. So it has identified some of the input parameters and given a range about it as well. Um, yeah, so transitions, probabilities, cost, utilities, others, etc. So yeah, so this is the it's just creating a list of parameters that can be used to populate this model. So I'll just continue to the next step. So I have gone through 5 steps right now, defining the disease problem, the disease pathway, identifying the model structure, identifying the health states and the parameters to populate these states. Now we'll summarize them together to generate a model specification document. Again, all of this is AI assisted creation, and this needs definitely need human supervision, but you can understand the importance of it in terms of downstream processes for creating, RFPs or some, some deliverables at the start of a modeling project. We can reiterate over it as well. We can go back and then again go forward, regenerate it. So a lot of, options are there. But one of the most interesting things will be that we can actually use this specification to generate a model on the fly right now using Excel and using the Claude functionality in Excel essentially. So yeah, that will be an interesting part of the presentation. Yeah.
And Shibuja, we've got a question about the document. So is this only based on the 2 documents that have been uploaded, or is it
Right.
include
Yes.
additional from other sources?
No, so it's as I told you earlier, that I just uploaded the 2 documents and provided the PICOs, and it's based on the whatever inputs I have provided, whatever information it has extracted from the documents.
So can it also get information from other sources, from the web or other LLMs?
Yeah, so from other LLMs is different, but it can get from other sources. So one thing is that it needs to be uploaded in a right now the app is designed that you need to upload the file, whatever, let's say KOL inputs. You can structure the document and upload it. Web search can also be there, but typically web search is gives limited inputs. Plus LLM has its own base of language knowledge or context. So that can also be used. But yeah, so it's not directly connecting to any other tool or any other platform, but as I think Ian will show that we can have a more integrated process in future. Yeah, so this is just the document that has been created. I can download it right now. It will be available for a Word file download, but I'm just downloading in a format called Markdown for now. And I'll just move on to the last step, which is a very experimental stage. It will most likely not work. What we intend to do here is that create something like a initial dashboard based on the specifications that we have generated. That, for example, you can probably generate a quick EJP and run some quick scenarios. And based on the model structure that has been identified, it can probably work for Markov and partition survival models as well. But this is a very experimental framework, which is that's why it was not included in the previous slide, because it has just been developed very recently. and it will probably not work as well. But the idea is that it can also function as an end-to-end tool. That's our intention, that it can give you like quick and dirty, estimates of EJPs and some settings, some results, etc. So yeah. So it's taking the parameters from the parameters inputs from the parameters file, and it will generate a very basic sort of a dashboard. Yeah. Yeah, it probably did not work right now because, again, as I mentioned, it's a very experimental sort of a nature. I'll just try one more time. In case it does not work, I will just hand it over to Ian. And just to show that this is the model specifications that it just uh, downloaded. This is the specifications that I just created and downloaded. It's in a something called a markdown format, but it can be easily converted to a Word file. This is another example of a similar model specification document, AD, but with a bit of changes that was done earlier. Yeah. So as you can see here, I mean, this is the idea. This is again just to give an idea. It will, again, as I mentioned, it will probably not work. But the idea here is that we will just have something like a model, quick model input. So it will take few of the efficacy inputs. It will take few of the global inputs. It will generate a base case result, the cohort traces, the cost effectiveness plane, and it can also generate a Python code for all the efforts. So it's not fully visible here, but this is a Python code that is generated based on whatever specification that have been provided. So it's fully transparent. You can take this Python code and maybe work upon it and build it further into any other tool other than Excel, like a Python-based model. Yeah. So yeah, I mean, this is the summary of the process. I know maybe I rushed through the process and some places it was slow, but it is essentially, it's giving you an idea about how the process of iterative development of a model concept can be done using the framework or the agentic flow that we are sort of conceptualizing. You can, anytime go back to these steps and again go forward. So yeah, I mean, you can sort of use it for playing around with your model specifications and tool development. Yeah. Okay, so before going on to the next step of model development, I will hand it over to Ian to talk a bit more about evidence generation part, which is a very critical part of any model development process. So yeah.
Thanks very much, appreciated. So I won't take too much time on this. I just wanted to briefly cover, as you said, Shubhajit, using AI to help us collect evidence that will be necessary for developing an economic model. As I'm sure many of you know, it's widely being used in literature reviewing, particularly for RCTs. It's obviously a major part of literature reviewing to collect the efficacy and safety data, but it's also quite easy because abstracts are typically standardized rather compared to kind of the more niche evidence such as HSUVs for a model input or looking for existing published economic evaluations. However, that isn't to say that LLMs can't do that. And in fact, we're seeing a really quite impressive performance by many different tools for collecting these data. So There are indeed many tools, as you can see on the slide. There are many different companies offering ways to search. They're typically looking at PubMed because it's open access, and it does cover a huge range of the existing published evidence. We ourselves are developing a tool called ActiveSLR Plus. Some of you might have seen ActiveSLR. It's an entirely free literature review tool that we released at ISPOR North America last year. This year, we're going to be developing a premium AI centric version that will allow us to automate screening and also use this targeted literature review tool that I'll be demoing in a second. ActiveSLR is entirely free and it will stay that way. So you could sign up, start using it now. I mention that because that is going to be the user interface that you will see. That is how this tool will look once we launch it in a couple of weeks' time. Now, the reason we did that, if we could just move to the next slide, please, Ray. The reason we felt it was necessary to create our own tool was to ensure that we maintain a consistent documentation of how we perform the literature reviews. So this TR tool is going to be our kind of one-stop shop, if you will, for creating a documented literature review like a human would. So we will create a natural language search, which will then be converted into a formalized PubMed search strategy. We'll automatically create the PCOS table, and then we will be able to run the search, filter and screen the titles and abstracts that were found. And then finally, not only having the outputs that are used for our modeling decisions, but also provide a quick narrative summary of what has been found. So that's the reason for why we were doing this. And so I'm going to now give a quick demo of the tool itself. Like I said, for those of you who have used ActiveSLR, when we launch this next month now, we'll be looking, you'll be seeing this in that ActiveSLR user interface that you're used to. But what we start off with is simply a question where an input box where we can put in any question that you want. So Shubhajit, you were looking at atopic dermatitis. So we'll follow that as well. So we look for health states utility values in atopic dermatitis. And then we will generate the PCOS and search strategy. So that's a natural language search bar. You can put in whatever you like. You simply then run it, and the AI will now be breaking that out into key elements. So we've explored different variants of this. You could put moderate to severe atopic dermatitis, adult patients. Those data will be separated out, and the LLM will now be creating both the PCOS table, but also the PubMed ready search strategy. So this will, when it then when it creates the input, we'll then see the created search strategy in the PCOS, which we will then be able to edit. So we'll just give it a second. Obviously, for those of you who know literature reviews, this would normally take at least a week or so, but 1 minute is quite an improvement. So first we can see that it's identifying atopic dermatitis and noting some changes in terminology, so atopic eczema. It's recognized that EQ5D, SF6D, HUE are all forms of utility elicitation, and it's creating a PubMed search string here. We can also see that it's rightly using a mix of mesh terms and medical subject headings, which are keywords, and also this TIAB, title and abstract designation. Now we can change this however we want. So for example, if we didn't want to look for qualies because we just want to have the raw utility values, we can get rid of that from our search term and it'll be fine to, it'll be ready to use. So we can edit this as we wish. And then what we can do is, I'll just get this running because it might take a second. But we also have the same search filters that you can see in PubMed. For the purpose of this demo, we'll show you a smaller number of search hits that will come through, but you also have the same years that are provided in PubMed. You can add these restrictions. You can also automatically limit it according to study design. So if you wanted RCTs, you could do so. If you were in a particularly data-rich area, you could look for systematic reviews already of economic evaluations, for example, and you can then choose finally what the LLM will do with any queries. You can either just have flag for review, which is our standard, where any uncertainties, much like a human, would be temporarily labeled as such, which you can then make a decision on, or you can adopt either a more conservative approach of saying, just if you're not sure, include, or a stricter one of excluding anything that doesn't meet all the criteria directly. This will then start running. It will create a PubMed. It will run the PubMed search. We can see here that is a pretty large search. If you wanted to, you could preview that on PubMed. You can click on that hyperlink and it will export that search straight into PubMed, and you'll see the results of it on the PubMed platform. Excuse me. After that, it's now simply just screening the 100 abstracts that it's pulled through, and it's doing it in batches of 15. So I'll switch over to an existing version that I have at the ready, which is, let me just go here. Perfect. And then we can see this one. So this is just an example that was run before. We can switch back in a second, but this is just showing you a very similar setup to psoriasis example. But in this example, the review has been run. In this case, we found 4 includes with 18 different unclears that I would be able to look through. In terms of the includes that it's found some relevant ones. It's got health utility in the PASI responses. It's got a mapping algorithm as well. So it's finding the right kind of data. We have the opportunity to export as well. Got a Prisma flow diagram there. And then we can finally create a narrative synthesis. So this will be, excuse me, it's just refreshed, but this would then create a narrative synthesis that would be able to summarize the work that you're doing, and then you would export it. So we just go back seeing how this one's doing. So this is where we are now with the initial version. As you would progress, this would speed up. We're looking to also optimize this so that you'd be able to review in a much faster time frame compared to this is going to take what, a couple of minutes to do 100 abstracts. But the expectation is that you would run this search, get it running, and off it goes in the background. You've got a progress bar there, but I think it's probably worth just also leaving it for now. So I'll hand
just
back.
to add.
Sorry.
Sorry, just to add here, there is some optimization work being done to make it much faster. Yeah.
We've got a few questions. We can always go to the questions. So just in terms of these are more for you, Shubhajit, around the previous tool. So how is the data extracted in the previous tool? So things like the mean, median, standard deviations.
Right. So that's a great question. It will generate some placeholder values based on the context that is provided. In this case, the nice TA that was provided, it will search and extract from there. However, it definitely needs human validation. As of now, the tool is not a data extraction or an SLR tool. It's more of a model concept and preparation tool and HE model initial sort of analysis tool. But it has some rudimentary capabilities to extract information from the context that is provided. But we will, what it does essentially is creates a list of parameters. That is a very handy thing that can be generated very quickly and probably can be taken to a tool like this one or Active SLR to generate, because they have more powerful algorithms and processes for generating the actual input values. But yeah, to answer the question, it has some rudimentary capabilities to generate to extract the inputs. but it will require human validation and probably a more detailed TLR or SLR. And and just to go through some of the specific questions, source traceability, again, source, the exact source will be given. I can show it in a minute where it's taking the data from. And numericals like mean, median, standard deviations, they are extracted from the document or the table that is provided in the given context. It uses LLMs and some framework to extract the mean and standard deviation. However, ActiveSLR and the other tools that Ian is talking about uh, are probably much better. Yeah. So I hope that answers, I think, 3 or 4 questions altogether. Yeah.
Okay, Ian, do you want to show the? I don't know
Yeah,
if
finish
that's
on.
finished. Yeah.
Yeah, indeed. So I'll just check to it. So yeah, we can see that this search that we did for atopic dermatitis has now been run. Of the 100 hits, we've got 3 that were found and some 8 uncertains that we would want to look through. The included list, we've got a cost utility model here. We've got an EQ5D5L bolt-on, which is looking promising, and another mapping algorithm there as well. So we have all these data and the narrative synthesis. I just ran that as well. This was AI generated in the last kind of 30 seconds or so while we're talking. It's covering, pointing at things like the EQ5D, but also the youth version. And we can, if needed, if you like to, you can always regenerate this. You can create a brand new version. The final thing as well is that throughout all of this, we're able to export everything. This will be an Excel compatible CSV file. This will provide all of the references that were reviewed, as well as the decisions that were made, including decision reasons. And as you'll see here, the decisions themselves are quite extensive. It doesn't have to be just a simple reference to a single PICO. The LLM is creating quite a complex justification for you. So there's a lot to be done here, and I think this can be done very quickly and save you a lot of time.
Okay. Shall we move back to you, Shabuja, and then you could do the demo for the Excel?
Yeah, right. So yeah, I mean, we have gone through the process. We have, created a model specification document that I just showed to you. What we will do is we will try to feed in this document to the Claude in Excel tool and generate a health economic model on the fly. So I've just opened a blank Excel. As you can see, there is it's not a pre-prepared Excel. I have a add-in of Claude, which you can install from the Anthropic website. It does require some subscription and licensing. So we'll not get into that in detail, but yeah. So once you click on Claude, it will open a panel on the right-hand side where you can write or type your text or instructions. What I will do is that I will just write a instructed to create a model, health economic cost effectiveness model based on the specifications provided. So I'll attach the specification that we just created and then let it sort of work through it. So, I mean, it will create, as you will see, it will create a lot of tabs, a lot of calculations, but yeah, it will require a lot of human input. So yeah, it has gone through the process. It gone through the document. It has identified whatever sheets need to be created, whatever assumptions you need to take. Uh, we can sort of modify it and add something. But for now, just for demo purposes, I'll just ask it to create it on its own. So as you can see, it has given itself a 8-step process to create the model. It's setting up the sheet structure, as you can see, parameters, transition matrix, Markov trace, cost and quality, results, TSA. It will take some time to do. I'll just let it do it for a few minutes. Then I'll move on to a bit more prepared kind of an Excel.
How long is it, Shabuja, roughly, for this sort of model?
It does take about half an hour, 20 to 30 minutes to create. model. So definitely we will not be able to show the full end-to-end thing because it will take some time. But I'll just show the starting few steps, how it sort of creates uh, the, the the specification. Yeah. I
We've
mean,
got another question about how does the software address quality assessments in the studies?
yeah. So maybe I I mean, quality assessment, it would follow the good practices in terms of SLRs or TLRs. It will give the prisma, it will give the full logical flow, it will have full transparency in terms of the um, Pico and the search strings or search strategy. The one thing to note is that it will only do a targeted or a quick literature search. However, the Active SLR Plus or the Active SLR platform we have is it's a very user friendly tool, and it adheres to all of the regulatory guidelines for creating a full SLR flow. And maybe Ian can add more on to that.
Yeah, sure. I guess we're talking about kind of a formal quality assessment checklist for a literature review. It's something that um, we're coordinating with incorporating into Active SLR that will allow that. That could then potentially feed into the decision making of things like selecting what type of quality, what type of quality should be considered as type of the model. However, I think if the question was pertaining particularly to inputs and selections from a model perspective, I think that's definitely going to fall into part of the human interface of double checking the decisions that were made by the LLM. These models will learn, and there can be improvements in that way. Certainly, if there was some type of systemic underestimation or incorrect use of data, that's something that an LLM will be able to learn with time. But that I don't think that will never be able to entrust full control to something like Claude. It's always got to have us checking those data from the beginning.
Yeah, and it's highlighting places where it's assumption and it's derived, and it does need quite a lot of human inputs. We have built quite a number. We have been working with it for um, a number of weeks and months, and it does need some human inputs. But the key effectiveness is that the shortening of time of iterative development. It will give you a first draft, and you can sort of go through the iterative development using Claude and also largely through the process itself, which which provides a turnaround cycle and testing assumptions and scenarios much faster. So essentially, we'll get first draft, second draft, so you can go through that much faster. As you can see, it has started to create the transition matrix, then Markov trace. It's creating, it's checking if the total is one or not. So yeah, I mean, a lot of the things that you would expect in a C model, it will sort of create. Just to show another prepared model, which probably shows some of the end state of this process. This is another prepared model, slightly different but similar specifications. And here it's fully created by the Claude or the agentic tool. It creates results and all the sheets, Markov traces, DS, deterministic sensitivity analysis. It can also start creating a PSA sheet, PSA, but it cannot interface with VBA directly. You have to input some sort of a VBA module, and then it can generate the code which you can paste, and it will generate the PSA, but it cannot directly interface with VBA. And yeah, so this would more be like the end product of what you would. One of the issues that we face while developing a model is that also that I mean there are many changes that may happen, and we sometimes lose track of all the changes that are done. So for example, here I have asked it to stop doing the PSA because I don't want it to do the PSA. So that's I think somewhere here, don't do PSA. and also add functional drop down for time horizon. So these two things I have asked it to do. And it has also added a log of it that these are the two things I have tried to do here. So yeah, so it's very interactive and you need to work with it a little bit. It does not, remove the human element, but rather I think human element is focused on, some of the more uh, uh, critical tasks.
Yeah, I
And
think
yeah, also, sorry.
yeah, when I've been using it, you requires you to go back and do a number of iterations. So you'll review it, you'll see some changes that need making, and then you reprompt and reprompt. So it does require a lot of skill as a modeler to use it, but still, you can see it reduces a lot of the fiddly processing
Yeah.
considerably.
Yeah, for example, one of our large task example is adding a new comparator to the model, right? So I can just ask it to add a new comparator to the model, and it will either use placeholders or ask me where, which sort of inputs or what is the plan it has to add the comparator. So it's a complex task to add a new comparator to an already existing model. But using Claude, you can at least start with it much faster. You can get the first draft much faster. For example, it's asking me who will provide the values. So I'll just say use placeholder values for now.
Just a couple of questions, Shibuja. Around the the yellow highlights that were in the other model, are those things that need to be reviewed?
No, so it's intermediate. It's highlighting itself for creation. Many times it is fixed input or derived cells that plot decides to mark as yellow, but it is likely that it will be color will be removed at the end.
Okay.
As
And
it's as
how
you see it's being created, it will take some time to create.
and how accurate are the models once Claude has finished doing
So
doing the
yeah.
building, the draft?
So we have seen quite good accuracy with simple Markov models, but when we work with complicated model, it still can give accuracy, but it depends on a lot of factors. For example, you can upload a model and you can ask it to run, but not every publication has all the inputs. So it's also a good way to find which data are missing from a particular publication. So what we have found is that maybe some of the key inputs were missing. That's why it's not able to replicate correctly. But I think, Ray, I think it's your article itself which matched quite well. I'll try to see if
Mhm.
I can dig it out, but it matched quite well. One of the a simpler decision tree followed by Markov structures. Yeah. Yeah. So accuracy varies in terms of what we input and how much we work through with it. It's not like AI is doing everything, it's just automating some of the tasks which typically used to take a lot of time. Yeah.
Okay. Should we move on to the last few slides?
Yeah, sure. I think, I mean, just to summarize essentially before we go there, as you can see, we have tried to show you an end-to-end process where we started with few of the documents like the guidelines and nice submissions. We walked through a guided process where few human inputs were there, and we can provide more inputs essentially. We had a guided process to build a model specification, a quick and dirty model, generate some Python code out of it, and then use that specification to build a proper Excel model. And once we build it, we can add on top of it, we can create a log out of what we do. So within the space of 1 hour of the webinar, we have sort of started from scratch and developed a model. Of course, a lot of caveats are there. Where are the inputs coming from? What is the source validity? We talked about the evidence sources and how we can sort of use AI for that as well, and also validation and verification. That's an important thing. But just to give you a glimpse of the agentic framework that we are sort of looking at here as future of health economic modeling. So yeah, I'll just hand over to you.
Okay, thanks, Shubhajit. So yeah, I think we've seen some of the how powerful the capabilities are. I think we're going to move on to some of the limitations now, and Ian is going to take us through some of those. So
Yeah. Thanks, Ray. Yeah, and as you said, Bridget, it's quite extraordinary what can be done in the space of that was more like about a 30 minutes demo, and we'd be well underway towards a working, a really solid first draft of an economic model. Obviously, we wanted to add a couple of caveats. It's things that we would probably discuss with our clients at the beginning of the project and make sure everyone's in agreement, but they are critically important and none more so than confidentiality in our industry. Data security is of paramount importance, and it's all the more important with LLMs because of how the data are used. There is no like email recall version on with an LLM. Were you to input confidential data into Claude, for example, that's out in the ether, that is gone, and so it is so important to ensure that there are no data breaches. There's nothing that is input into an AI that you wouldn't want publicly available. So it's a strong recommendation. Make sure that there is very clear processes in terms of how you manage that confidentiality. A PharmaQuant, the way we do that is ensure that we do a placeholder on the architecture. The example Shubhajit gave was ABC versus XYZ drugs. We will put in placeholders rather than using actual therapies. We will ensure that no commercially sensitive data are used. And the aim here is to create all of the architecture without any of these data, which can then be substituted in by humans, by the PharmaQuant team. We then do this entirely as the traditional way dictates, but that allows us to do that in a way that is adherent to client SOPs, data integrity requirements, etc. So it's important to do that and ensure as well, the final one, ensure we have an audit trail across all of this, how it was developed, how we then substituted in those data to ensure that it's clear that there's been no data exposure to any model that you don't have total control over. So the final slide I wanted to end on were just some kind of wider potential pitfalls and things to be mindful of. I guess a couple of them you've no doubt heard of: hallucinations and bias and drift. A couple of those examples would be hallucinations, would be using a totally fictitious reference for model inputs. If it's presenting a nice TA as on your model spec that is nothing to do with the disease area that you've presented and is or is redacted or whatever, then there's an indication there that there's been something odd that's gone on with the LLM. And that leads to the point again of making this very clear audit trail, keeping the human involved at all points. And I think that leads to the final box I wanted to cover, which is the top right, which is the criticality of using a trained team. You have to have this Venn diagram of both health economics and outcomes research experience and AI expertise. They have to go hand in hand. Were you to have AI expertise without understanding the HUR world, you would be prone to many of you'd be exposed to many of the pitfalls that we've seen here, and vice versa. So our strong recommendation to our clients is ensuring that you have that right team, that you're working with a vendor that has both of those sets of skill sets, and they're bringing that together within the same team that you're working with. So I think that it's just a little pit stop. It's something that we would talk about extensively for any such projects, but it leads nicely on to a few of the points that Ray wanted to cover about the right team and particularly how we work with our clients with solutions such as we've shown today.
thanks, Ian. So we've just got a couple more slides. So this is really about at the end of the day, we want AI to be able to empower HUR teams and health economists and I know we're all exposed to AI, we hear it all the time, but really it is. I think it's a reality. Things are changing. The industry is changing, and we can see that this coming. So really, sort of in terms of workflows, that what we focus on is making sure that AI is integrated, that it's able to help out in the more mundane things. So on the left, things like repetitive analysis, data gathering, summary statistics, gap analysis, comparisons, sort of but basic TLR reviews. So things that can be automated. And whereas the HR team focuses on more the strategic side. So what is the decision problem? How can we define the scope and the research questions for the project, for the models? What sort of confidential data is there? How is that analyzed and how's that used? Directing the AI agents as well, making sure that they are doing what they're supposed to be doing and that they stay within the remit provided. There's a big role is QCing and reviewing because as Ian has said, there are lots of drawbacks, and when we've seen the models as well, you've got to remember that those are AI generated models and they need a person to check that it's doing what it's supposed to be doing. Sometimes AI throws out contradictions and trade-offs that need to be resolved, and also materials need to be approved. So AI can augment what the team does, but the HR team is in control and has to make sure everything is done properly. So AI can add value, things like productivity, so making sure that there's additional outputs from the activities, that things are done efficiently. It can provide extra flexibility, so you can change your strategy and it can restructure the models. It allows you to be adaptable, to pivot quickly to different situations and be responsive as well. And in terms of, and hopefully this will enable the HR teams to focus more on things like the strategic insights, applying their expertise, which AI can't replicate. There's a clinical and payer inputs, so making sure everything is contextually appropriate, making sure that the methods are appropriate, that rigor is applied, and that any choices are defensible, that you are, and that we're trusted advisors. The value stories still have to resonate. Again, that's something that only we can check. And at the end of the day, someone's got to be accountable. There's no point. We can't blame the AI if it all goes wrong. So we'll always be accountable for that, for the final outputs. So the last slide, this is more about PharmaQuant and how we work with our clients, how we work and how we can provide support when it comes to AI. So this is our last slide, and it is a bit of a pitch from us, but we want to, we have different engagement models. We're currently working with a range of different clients. I think, like I said, we know AI is here, it's coming, it's going to change what we're doing. And so we're looking not just to provide support now, short term on projects, but to guide clients through this multi-year transition, which will see AI being incorporated in workflows and day-to-day activities. So there's different services that we have, like consultation, where we can provide look at workflows and proof of concept and provide different solutions. We have ready-made solutions like what you've seen today, which can be subscription based. And then we also have bespoke AI solutions, so we can build teams specific for your team. So if there's a particular need, we have the ability in-house. The tools that you've seen, like I said, we started this in January. We've built those up over the last 2-3 months. So we can build solutions to meet different needs. We can also host these on our systems or your own system. So we have a number of different deployment options. And in terms of why you might want to partner with PharmaQuant, we are a small team. We're able to be very agile, make decisions quickly and develop things quickly as well. We're HOR experts, so in literature reviews, ITCs, stats, models, and value communications. So we're also developing, we've got tools for GVDs, ITCs, and also dashboards as well, value communication dashboards. And also we're able to provide end-to-end delivery for these solutions. So we do hope that you do reach out to us. We'd be very happy to continue the conversation further. It has been a bit of a whistle-stop tour, but hopefully we've showed you enough to show you the potential that AI has. So with that, maybe we can go on to, if you've got any questions, do jump in, Shubhajit.
Yeah, I think there were some questions about accuracy, so I will just show replication of one of your publications, Ray. So this was the publication, and in the respiratory disease area. It's a published article by Ray, and if you look at the results, if I compare side by side, it's not 100% accurate if you see on the screen right now, but it's pretty much close to the ballpark in terms of the result if you just compare total and quali and total and quali table. So just to give a glimpse of that, I think there were a few questions about accuracy. Now, I mean, maybe for model articles or situations where we don't have the full data, or more complex models, it will not be accurate at first draft, and it will need guidance and right way of using it to sort of edge it towards more accuracy. So yeah, I mean that's a sort of a short answer to that. And yeah, so just wanted to mention that today, because since that was one of the questions. Yeah.
Okay, we've got a question about the slides. So yes, we will email the slides out after the presentation. So over the next few days or so, we also plan to upload the video to. So this is being recorded. So we plan to upload it to YouTube at some point as well. Okay. Were there any other questions, or Ian, Shibuja, anything else in the chat that?
Yeah, maybe I can go through some of the chat items. So I think one of the question is whether Claude will retrieve the clinical data, and I mean it will do extrapolations on its own. It can do extrapolation on its own, but clinical data definitely should not be added at this point with Claude. It will require some, as Ray mentioned, in terms of on-site development, some collaboration with the IT team to set up structures and processes in which it can be updated. But as it stands in the demo itself, we cannot upload the clinical data. It can do extrapolation on its own based on published KM curves, but that also needs some human accuracy, human input. Typically, our SOP or process is that to use a placeholder and then add in a different environment, essentially, where we are sure that we will not be uploading any data to AI. I think there was another question in terms of how much complexity already inbuilt in terms of drop-down options for different inputs or second line. So here, I think there is a sort of a push and pull that in terms of our tool we are working towards, that we want to keep it sufficiently general for varied use cases, but we will let the tool create some sort of dashboard or some sort of a drop down for the dashboard section itself. and probably we will have option to update it. So it's a sort of somewhere in between as full structured versus fully, random by AI. So that's where our expertise comes into the picture, that we are able to structure it in a right manner and create processes or frameworks for that. In terms of the Claude itself, it will need in a tool itself, if you want to build up various scenarios and complexity, it will need human guidance unless it's specified in the model specification. So you can create it using the model specification, and then it will just, based on the instruction given in the model specification, it will create it. Yeah, so these are, I think, two of the questions I tried to answer. And accuracy, again, like it's an evolving space. We are working towards a lot more future white papers and publications using our framework, where we will have much more detailed evaluation matrices of how it sort of increases efficiency. But we do see a lot of scope of efficiency, and we have seen it in some of the projects or some of the examples we have done. Yeah, just stop here. Yeah.
Okay. Any further questions? Okay, maybe then, unless Ian Shubajit, any further comments? I'll just.
I think so.
Okay, just to let you know, so as I said, please feel free to reach out to us if you've got any further comments or questions. Ian and I will both be at ISPOR next month in Philadelphia at the PharmaQuant stand. So do drop by. We'll be doing some further demos. We've got some other tools that we have, and we can have further discussions though. So feel free to reach out to us. Like I said, we'll send through the slides, and thank you for your time, and hopefully we'll be in touch soon. Okay, well, thanks everyone.
Thanks so much.
Thank you.
Thank you. Bye-bye.
Bye.